So, as soon as I finished the nuclear chemistry video, I realized I did not talk about half-lives. So, this video is dedicated just to half-lives. So, half-lives are the amount of time required for half of a sample of a radioactive material to become stable. And this is a exponential. It's exponential. If you're in pre-cal, advanced pre-cal, right now we're doing exponentials and logs, and so we've been doing some equations with half-lives, but this is another way to do it. So here's the first example. We did do this in class, but sometimes it's just good to hear it explained again. So say you begin with 5.32 times 10 to the 9th amount of a substance sample, and you end 5.20 times 10 to the 6th. And the half-life of this substance is 3.1 hours. 2.1 hours. So, how you do this is you divide the two things you know. So see, we have the beginning time, we have the beginning amount, we have the end amount, we have the half-life, we don't have the total time. That's what we are trying to solve. And so, first we divide these two. So, that is fun. Okay. Nope. Okay. 5.32 times 10 to the 9th divided by 5.20 times 10 6. So obviously you put this in your calculator. You can use the EE button and then just put in the subscript or the exponent to get to do this. And so that equals 1,023.08. And so now the way you can think about this, especially if you don't know logs, is how many times, like 2 to what power would get you around this number. And so 2 to the 10th gets you to 1,024. And so that means, so this exponent, this unknown is 10. So that means it took 10 half-lives to get to that amount. So then you take the time, the half-life time, 32 times 1, times the number of half-lives, and that gives you 321 hours. And that is your answer. So that's how long it took for this sample to reach its half-life. Now, let's say we begin with 5.80 times 10 28th. We end with, we don't know. But our total time is 3.03 times 10 to the 6 years. And our half-life time is 3.79 times 10 to the 5th years. So again, for these problems, you start by dividing your two knowns. So this time we know the times. So we divide those in the calculator. And so that gives us 7.99472 years. So that's about, when you round up, 8 half-lives. So we know the substance underwent 8 half-lives. So what we're going to do is we're going to take our starting amount, and then the unit would be atoms, and then we're going to divide it by 2 to the 8th. Because as we know from the last problem, that exponent is our half-lives, and you put it on top of 2. So that gives you 2.27. Remember sig figs, so we need 3 times 10 to the 26th atoms. So that is how much you end up with. So that is half-lives. You can also use logs, I believe, if you know logs, but this is how it's presented in class, so that's how I'm going to teach it. And so, yeah, that's half-lives. Thanks, everyone.